where all these points are, and I'm taking them to the meter line, so I'm only getting half the story here, but this is the quickest way to do it. Okay, so there they all sit here. Now let's bring those down this way. And let me make again a different color. Let's see, let's go with green on this one. And again, I'm just going to copy it. So there I'm bringing them down. Now, you can kind of see how they're all falling apart, or falling together, in that I've got a grid down here, where here's my height, there's my depth. All I need to do is follow my grid because I stayed equal numbers all the way. The big thing here is look where your holes are. Look at when you get these flat surfaces, look how much distance there is between those, and look how little there is here. Keep in mind, you can tighten this grid up any way you want, just add another line. So if I see in here, you know what, I don't know, I don't feel real good about this, there's too big a distance, I'm going to go at it. It doesn't matter, all I'm doing is picking an arbitrary point. So I'm going to use my nearest snap on this one, and I'm going to fill this hole in. And let's just kind of grab a spot halfway in between. So I'm going to bring it from there to there, and then down. And I'll just leave this one that off color so I can find it. And it was right here. And I'll bring that one down till I hit intersect, and then I'll bring that back over. Now, all I got to do is follow this grid, and I'm going to use the P line to do it. And I'm going to come up here where it starts, and I'm just going to kind of follow this grid, moving over and down one as I go. If you did it correctly, you should hit the center point at the bottom point. If you did not hit that, you got a little
You screwed up.
confused on the grid, which can happen to me many, many times. That's why I've gone to where I use colors. Okay, let me delete all this stuff. There's my circle. Okay, so this is a P line. Again, I'm just going to take this guy, I'll mirror it from one side to the other. I'm going to use the join command to put them together, and then I'll go into P edit, fit it to a curve, and there it is. Now, this one was approximated with points. Okay. How close is it to the other one? Okay. Well, let's go look. Let me switch this to, let's go to the border layer on this guy, and let me copy this from here to there. You can see there will be differences. Okay, like the yellow line here is the true ellipse. That's pretty much the perfect representation because I was able to find my quadrants and axes. This one's the approximated one. This is so close, I bet you, I've got my thing set to 3 units, I'll bet it doesn't record a distance in between them. Let me just check the distance of this. Let's go from there to perpendicular, this guy. Yeah, to 2 decimal places, not even recording. Okay, so that's a very small distance. You will never pick that up on a print, that difference. But it's approximate. In essence, you took the curve, you defined it into a bunch of points, and then you projected points. So both of those get it for you. Let's go ahead and finish this guy off so we're complete. We still have a trench going on here that goes from here, goes all the way to this bottom surface right here, and the width of it, or the depth, excuse me, is right here. I'll bring those over. And there is my surface. So I'll trim that out, those, that. Let me kind of clean it up. Okay, so it's all those. Don't forget, this is gone too. That's been cut out also. And there is your finished projection. These are a hoot. Have fun with these. I mean, they test you. It's kind of like those missing line worksheets, you know, that after a while you kind of frustrate, but when you solve them, they're pretty darn fun. Good sense of accomplishment. Pretty difficult, really, folks. If you can do this, it doesn't get much harder than this. An irregular surface, that's about as hard as it gets in this world, is that type of projection. If you can project these successfully, you'll have no problem with a house. That's easy. Because they're all linear surfaces, right? You'll have no problem with, I don't know, doing a sewer line. They'll all project 10 times easier than this. There's a reason we're teaching this in the mechanical engineering field, because it's the hardest geometric field to work in. You really got to know your geometry. If you can do this stuff, you can transition to any discipline, and you'll just be the projection guru. Everybody will be coming to you and say, how do you do this? How do you do this? I still remember the first time I saw this done, a guy named Rob Copen did it. Man, I sat him down for a second, you got to show me how to do this. That is just cool. And we took a half hour and he showed me how, and that was many, many years ago.
To do one?
Yeah.
And now it took you how long to do this? 20 minutes? 10?
Yeah, I don't know. Like that first one you could do in maybe 2 or 3. But keep in mind, this was back when we had AutoCAD with no mouse and things were a little slower. All right, so there's that. I hope that helps you out on that. You've got through G4 to do. If anybody think they're going to finish G4 today? Okay. I better get the next assignment ready.
Oh, no, that's okay.
When you finish that, come see me, please.
We'll be finishing that soon. End of the day.
That is what you guys get for admitting to this crap. Way to make it hard on yourself.
What's that?